Now till now we have seen what happens with the data structures, or what are the data structures required on the hard disk, right? So what are the blocks required and what are they containing? Now we shall see, in order to implement the file system, what are the data structures that are required in memory. Now why do you want to maintain some data structures in the memory as well? Because if you store some information in the main memory, it will be faster to access instead of always going into the hard disk and getting the information. If we can buffer it in the main memory, it will be faster sometimes to get the information, right? It will improve the performance. Now let's see what are all the in-memory data structures we are going to use in file system implementation. Now the in-memory data structure is used for both the file system management and the performance improvement via caching. So we are going to maintain some data which will be helpful in managing the file system, and also it is going to give us performance improvement. So how is performance going to be improved? If we have something in the main memory, it will always be easy for us to get it compared to the information which is present in the hard disk. This data loaded at mount time. This data is loaded at the mount time and discarded at the dismount. So whatever data I am telling you, it is going to be loaded at whenever you are going to mount the file system, and whenever you unmount it or dismount it, you are going to delete the data. So what is mounting and dismounting is, whenever you connect a new hard disk or let's say a new partition or a new volume to just even a pen drive, if you connect it to the computer, it is called as mounting. And whenever you mount anything like that, you have to get all the information which is present in that particular device into the main memory. So what is information that you need, like what are the files present in that, what is the directory structure, all such information, right? Now let's see what we get here. Now inside the memory we are going to have something called as in-memory mount table. So this table is going to tell us about what are all the hard disks or the partitions or the devices, memory devices, which are connected to the computer, right? Now it contains the information about each mounted volume. So either it is a pen drive or a hard disk or a DVD, whatever it is, whenever you connect it, we are going to see that in the table, right? That is called as in-memory mount table. And the next one is in-memory directory structure cache. It holds the directory information of the recently accessed directory. So whatever directory you have recently accessed, that information will be present in this one. So why should it be present? Because if you have recently accessed a directory, it means that you might have got that directory structure block from the hard disk or that particular volume into the main memory. If you have used it now, there are chances that you might again use it, so you can save it for some more time. That is why it is going to save it for some more time. That is why it is called as cache. Cache means it is going to save it temporarily for some more time. And the next one is system-wide open file table. Now in the entire system, you might have opened some files from various devices, right? Now what are all the open files? That list will be maintained in this, right? System-wide open file table. This is going to contain the information about all the files which are being opened by the operating system currently. It contains the FCB of each open file, right? What is FCB? File control block. It gives the information about the entire file. If a file is already open, you should know about it, and you should know the status of it, because if you want to access it again by some other process, you have to look at it, okay? And the next one is per process open file table. So I told you that every process is going to maintain something called as open file table. So every process is going to open some files, and entire information about the files that particular process has opened is going to be present in this one. So for every process there is going to be one open file table. Now if you observe this, already we have system-wise open file table. It is going to contain all the files which are open, and this one is going to give us which process have opened those files. Therefore the information is same, but just the organization is different. Here all the files will be listed out, and here only the files which are opened by a process will be listed out in each file. So that is why what we can do is we can maintain some pointers. I'll show you what. It contains the pointer to the appropriate entry in the system-wide open file table. So what it means is, let us assume that the system-wise open file table is going to say that file number 1 is open, file number 10 is open, file number 21 is open, file number 30 is open, file number 31 is open, and file number 41 is open, right? Now these are nothing but the file control blocks of these particular files. Now if there is a process P1, and if the process P1 has opened the files, let's say F1 and F10, now it need not contain again the file control block, isn't it? If a process P1 has opened F1 and F10, it need not again replicate that file control block of F1 and F10 again. Since it is already present in this table, it can just have a pointer to this. That is what the meaning of it, right? Now this is the system-wide open files. This is per process open files. Anyway, when a process has opened a file, that information is going to be present here. Therefore, instead of replicating it again here, we can directly point to this, right? So all these structures and all this information, it is all going to be present in the memory. That is why these are also called as in-memory data structures, right? So till now we have seen the disk data structures. Now these are the in-memory data structures which are going to help us in improving the performance, okay?